Greetings and welcome back as we continue our discussion on the respiratory system. So today we're going to talk about the lower respiratory system. And so with that, you'll be able to describe the structure and function of the trachea. Why do we have it? What to do? You identify branches of the bronchial tree and understand how they change. We're going to talk about structural differences between your left and right lungs. And we're going to talk about your visceral and parietal pleura, along with why we have them, why they're important. So for starters, again, this is your lower respiratory system, so everything below the larynx. Your trachea, also known as your windpipe, is a flexible cylindrical tube, roughly 2.5 centimeters in diameter, about an inch, and it's 12.5 centimeters long. So give or take a little bit, 4 or 5 inches, 5-6 inches long. Extends into your thoracic cavity, enters the lungs. It's located anterior to the esophagus. So if you get hit in the throat, you will hit your trachea before you hit your esophagus. And it's lined with mucus, which filters the air that makes it pass through your nasal cavity, through your larynx. So we're still filtering the air so we get as pure air as we can into your lungs. So in this case, so we talked about the pharynx mucus moves down towards the throat. In this case, cilia moves the mucus up the windpipe into the laryngeal pharynx, and then so it can be swallowed. So it goes up this way and then down into your stomach where it can be destroyed effectively. Okay, so your trachea is made of these C-shaped cartilage rings, and the function of these C-shaped cartilage rings is to prevent it from collapsing. So based on pressures, when you breathe in and out, you're creating a low pressure system in here. So the high pressure on the outside would collapse your trachea. You would cease to breathe if you didn't have these cartilage rings there. And you will notice that there's cartilage most of the way around, but there is this little gap that is held together by smooth muscle. So it is slightly flexible, which is why you can bend forward and backward and side to side and all that sort of stuff. Is because of this. So it's not just straight cartilage. There's a little bit of give to it. In the case of you can't breathe, in an emergency situation at a hospital, sometimes they perform what are known as tracheotomies, which is where they actually puncture a hole in your throat beneath your larynx into your trachea so that you can breathe when your larynx becomes obstructed. So you can't breathe, you have something lodged in your throat. They will cut an opening in your throat and allow air to get through that way. That's called a tracheotomy. Okay, down beneath your trachea. So air goes from the larynx through the trachea and it has to get to your lungs. We call this the bronchial tree. So the bronchial tree is branched airways leading from the trachea to the air sacs in your lungs. You have several different layers to this bronchial tree. The first split. Your trachea splits into your right and left primary bronchi. This happens about your 5th thoracic vertebrae. This is where they split. So this would be your right primary bronchi here. Your left one would be here. Okay, so it's this first major split off the trachea. From there, it splits into what are known as secondary bronchi. Each of your secondary bronchi enter a lobe of the lung. So on your right side, you have 3 lobes, so you have 3 secondary bronchi. On your left side, you have 2 lobes, so you have 2 secondary bronchi. So that's split number 2, the primary, secondary. After the primary and secondary, we go into what are known as tertiary bronchi, or segmental bronchi. I call them tertiary. You have 10 of these on the right side because, again, you have an extra lobe, and you have 8 on the left side. Okay, beneath that, we have what are known as intralobar bronchi, which enter these things called lobules, which are the basic unit of the lung. I don't worry too much about this portion. You need to know primary, secondary, and tertiary up to this point. Intralobar is kind of icing on the cake. I'm not going to hold you to that one, but just so you're aware. But these are your splits. So again, you have your trachea, your primary bronchi on either side. This splits into secondary, so we have 1, 2, and 3 secondary bronchi. And then as we get down, we're going to split into these things called tertiary, which are here, and we get down into bronchioles and alveolar ducts. So these are your respiratory bronchioles here. So you have terminal bronchiole, which is the last split. Respiratory, which goes into these alveolar sacs, which are connected by alveolar ducts, and eventually your alveoli. Okay, so skipping your intralobar bronchioles, we need to get to terminal bronchioles. These you need to know. and there are roughly 50 to 80 bronchioles in a lobule of the lung. This goes into a respiratory bronchiole. So again, these sacs are called respiratory bronchioles here. And so 2 or 3 of these bronchioles branch from each terminal bronchiole. From the respiratory bronchiole, we go to alveolar ducts, which are this guy, and then into alveolar sacs, and then into alveoli specifically. Okay, so those you need to be aware of. You can skip the intralobar. You need to know the terminal bronchiole. I think I kind of grouped these two together, terminal and respiratory, which go to your alveolar ducts, alveolar sacs, and alveoli. Those are the terms that you need to be familiar with. When we talk about your alveoli, your alveolar sacs, an alveoli is a thin-walled opening pocket, essentially. It allows air to diffuse into the blood of the capillaries. So you notice these guys are surrounded by capillaries, blood vessels here. They're very thin-walled, so oxygen and carbon dioxide can diffuse back and forth with ease. And so on this side you have, it's shaded blue to show that it's deoxygenated. And then when it becomes red, it shows that it's got oxygen. So we have deoxygenated blood comes to the lungs. It gains oxygen, releases carbon dioxide, and leaves the lungs with that oxygen. And so this is the reason we have lungs, is to get oxygen to our blood. Okay, so your whole function of your bronchial tree is to transport and filter air. That's the goal. You have approximately 300 million of these little alveoli, these little sacs in your body. If you spread them out, you could cover 80 square meters worth of space. That's incredible. We have 80 square meters worth of material packed inside our lungs. Our lungs aren't exactly huge, but that's amazing. And the reason they have thin walls is for this gas exchange, oxygen and carbon dioxide. Here is an X-ray image, and so you can see your blood vessels. We have our capillaries surrounding your alveolar sacs, your alveoli. Okay, same thing here, shown on both of those pictures. Okay, lungs as a whole. Your lungs are soft, spongy, cone-shaped organs in the thoracic cavity. You have 2 of them. Your heart lies in the middle. And so your right lung has 3 lobes, your superior, middle, and inferior. Your left lung has 2 lobes, your superior and inferior. The reason your right side has 3 and your left side has 2 is I want you to think about where your heart is located. When we put our hand over our heart is on the left side of our thoracic cavity. So the reason we only have 2 lobes here is that third space where that third one would be is taken up by our heart. And so your lungs are bound by the thoracic cage in the front and back, as well as top. So anterior, posterior, and superior are all surrounded by your thoracic cage, which is your rib cage. And then on the bottom side, your lungs are lower boundary to your lungs is the diaphragm, which controls whether air goes in or out. And we'll talk about that, I believe, in the next unit. Okay, but here you can see your lungs resting right up against that rib cage, and then on the bottom here would be your diaphragm. Okay, so here we see our trachea coming down. We don't see the branches, but you can notice the lobes. We have our inferior lobe and superior lobe on the left side. On the right side, so again, remember, we name things based on the person we're looking at. So their right side is going to be a superior lobe here. Whoops. The superior lobe is going to be here. Our middle lobe is going to be here. You can see the split there. And then our inferior lobe is this little guy off to the side. Okay, so those are your lobes and your lungs. Okay, your lungs are supplied with blood and oxygen. And the way this works is they are they're permitted into this space through what's known as the hilus or the hilum. I believe I usually use the term hilum. Okay, and there's 2 layers of this connective tissue. And again, we're talking about the lungs. So this is called the pleura. So we have our visceral pleura, visceral being innermost. This is connected to the lungs. And we have your parietal pleura, parietal being on the outside, which is connected to your thoracic cage, your rib cage. In between these 2 cavities, you have serous fluid, because this is a closed body cavity. This does not open to the outside. So this is a serous membrane, and in between these 2 layers there's this substance called serous fluid. And the reason for the fluid is lubrication, so that when you breathe, your visceral and parietal pleura do not come in direct contact with one another, which would cause friction, which would cause pain. They could potentially rupture, which would leave a whole bunch of issues for the individual there. If we have this situation called pleuritis, so again, pleura refers to the lungs, itis refers to inflammation. This is essentially inflammation of the pleura caused by friction. So this is when it is become painful. It makes it difficult to breathe. It's painful to breathe, not something that's real enjoyable for most people. Okay, so here's a look at your left lung, right lung. You have this visceral and parietal pleura. Notice the gap in between here is very, very, very minimal. There's really not a lot of space, but it is covered and surrounded by or filled with serous fluid to prevent that friction. Okay, this is showing you the section taken, so we're cut here. This is what we're looking at. But these are your different structures within your thoracic cavity. So this is your heart surrounded by your pericardial cavity, and then you have your lungs on either side. Okay, again, just a different angle showing you the same thing that we have. In this case, this is your spine. Coming down, we have your lungs. This is your heart here. Your lung is on this side, showing you where you have your veins and arteries coming in and out there. This is your atrium, which will split into your three branches, and the rest of it comes down to, or your aorta, sorry. It splits into your three branches and then goes down to the inferior region of your body. Okay, I would like you to be able to answer these questions. If you have questions, please let me know. Otherwise, I look forward to discussing this more with you when you return to class, and I will see you next time. Thank you very much, and have a great day.